Hello and welcome to a very special webinar, Direct-to-Chip Innovation, Revolutionizing Data Center Cooling for AI and HPC, presented by our friends at ECS Compute Solutions and Accelsius. Our panelists today are here to discuss their unique collaboration, as well as some real-world applications to help data centers meet the rising demands on power and cooling created by high-performance computing and AI workloads. So without further ado, let's go ahead and jump in and meet our experts. They are my old friend, Mr. Jay Lawrence. Jay is the CEO of ECS, and Mr. Josh Claman. Josh is the CEO of Accelsius. Gentlemen, welcome to the webinars, and let's go ahead and jump right in to some questions. Jay, we're going to kick these off to you. Josh, if you've got some color to add around the questions I have for Jay, feel free to chime right in. So I want to talk a little bit about the collaboration first, specifically with regard to rising power density and thermal management challenges increased in the data center. Jay, to you, what are the heat management needs for high performance compute and AI applications?
Well, Dean, thanks for the introduction. Good to be with you again. And Josh, welcome to the party. So again, let's try to make this fun. I'll start with my generalized answer and then we can kind of dive in. But I would challenge anyone listening to go to a car lot today and try to buy a air-cooled car. It ain't going to happen. So when you look at what's going on with compute, there's a couple of things. One, I always say, and I'm a recovering telecommunications guy, so I always say follow the network. And people don't realize, I think when 5G came, it was so much more disruptive than the 2, 3, 4 LTE. And then you get to 5G, which ostensibly decentralized the central office, moving the compute requirements further and further out to the edge. One, where you have less power because the power grid will ultimately follow the network. So preservation, not just of thermals, but getting the most efficient deployments possible is essential. When we looked at the ECS strategy, we said there's really three key tenets. One of them is the telecom network. The second is artificial intelligence, of which I think is it's in its infancy. It's still the early sugar high. And those chips are just getting hotter and more dense. And then three is the liquid cooling component. And that's where Josh and I became buds. Because in the end, it doesn't matter if you run out of power, you aren't putting your data center on the line. And we're seeing more and more of this. So we went out, studied the market, looked and looked and looked. And the two-phase technology that Accelsius brings us is extremely slick. Matter of fact, we have it in our innovation center, so come see it. The best part about it is it works as advertised, actually a little bit easier than advertised. And, we've been at this for what, Josh, about a year now?
Yeah, about that.
So it really comes down, Dean, to the fact that these chips are not just getting higher in thermals, they're getting denser in the rack. The power outside the building, whether it's a big, 300,000 square foot data center or one of these new micro data centers, there's just less of it. And I don't care what anyone thinks is going to happen with power. You just can't flip a switch and get more of it. So one of the things, and I wrote about this in Greener Data last year, and spoiler alert, I'm going to get a little bit more verbose about it in the upcoming one, because it's a practical matter. Yeah, we got to figure out how to do more things to create more power. But, the smart person figures out how to do more with what you've got first. And that's what Accelsius helps us to enable, is when we build these very dense compute platforms and, HPC, AI, those are all the nice buzzwords, but they're just denser. And it's not just denser in the rack. It's again, follow the bouncing ball of the network. These things are moving into edge data centers that don't look like your beautiful Equinix style data centers that have climate control and fences and gates around them. They could be in hollowed out, strip malls that the brick and mortar businesses didn't need anymore. But you need to get, because the network says latency matters, and it matters big time in certain forms of AI, getting to that edge and then preserving the power and letting those chips be able to run full throttle. And that's another key thing that Accelsius brings, is once you get up, the H series GPU from NVIDIA recently discontinued, that's a 700 watt chip. You start getting into the Blackwells and what's coming next, you're 12, 15, 3,000 watts. Single phase technology is just not going to get there effectively. So that's part of I think the magic between what Accelsius brings to the table. Again, it's a key tenet of our strategy because the cooling, if you can't cool it, you can't run it. And again, I'll close with my open. Go to a car lot and try to buy an air-cooled car today. Unless it's like a Model T, you ain't getting it.
Or I had a 72 Volkswagen Bug way back when. So and yeah, so I could run faster than it could drive. So, but look, Jay, help me out a little bit here, because when it comes to cooling, we hear a ton about cooling right now, and everybody kind of seems to have their own flavor and their own kind of strategy with regard to cooling. But let's talk a little bit about direct to chip, specifically why you guys feel direct to chip is the way to go.
Well, a couple of reasons. The first thing is customers, the people that we care the most about. Those are the ones who write the checks. So we got to take care of them.
I hear that.
But people are more comfortable with things that look like what they're used to. But it's also works can't cost extra. So when you look at direct to chip, if you look at a Celsius rack with our compute technology integrated into it, well, it looks like any rack you would see almost in a data center today.
Mm-hmm.
The other bit is one of practicality. And I mentioned the comment about where these chip thermals are going. You get to a point with single phase technology where you just can't yank enough heat off. So that's where Accelsius's technology, which we've tested alongside and with them, and again, are running it in our innovation lab to continuously work with them to look at new applications and whatnot. We know that it works. And again, works can't cost extra. The other bit is if you look at how data centers are built, right? They're built to handle racks right now, not tanks.
Mm-hmm.
So, people will talk about immersion, and I think there's a place for immersion, but direct to chip, the two-phase specifically direct to chip is, in our assessment, the most efficient and productive way to handle putting fluid over a chip and extracting heat. Two, the safety and protective mechanisms that Accelsius's technology has, and I'm sure Josh will want to chime in and talk about that. And Josh, feel free to interrupt because I probably can't do your project as good a justice as you can, but I'm certainly happy to vouch for how good it is. But what people talk about liquids in data centers, like, oh my God, it's going to leak and there's going to be puddles. Well, that's true with some technologies, not theirs. So again, you start with the customer. What the customer is trying to do. They want to run really hot, accelerated computing all the time. And AI, by the way, is always on.
Yeah.
Right. AI doesn't take a nap. It's always on. So you've got to find a way to get those chips protected, cooled in the environment, make sure that it's safe and secure. And by the way, you get all those green benefits, which customers like too, because they're saving a bucket of power because they're not having to blow those fans, and you can run a little bit hotter in the environment. There's just a lot of good pickups that you get. And that's part of why we look at direct to chip as the solution. And again, two-phase direct to chip is the way to skin this problem. And it's the future.
Outstanding. Brilliant segue into my next question. And this one is directed to you, Josh, the expert here. Your Accelsius was founded on the thermal research. So why don't you talk to the viewers a little bit about your technology and your team and how things develop there at Accelsius?
Yeah, well, let me maybe back up a little bit and talk about just our perspective on the market and sort of why we do what we do, which is two-phase direct-to-chip. And I think Jay hit on some of the important points of that, right? Some of the important reasons for that. But, there was a rush into liquid cooling. And I think that there's some inertia, some maybe cultural inertia, some conservatism in the data center sector. For a high-tech sector, it is pretty conservative. Yeah. So 3 years ago, when we founded the company, there was still quite a bit of debate about air versus any type of liquid cooling, right? Now, for those of us who were sort of ingrained in the science, that was sort of an absurdity that we just knew we had to overcome. And certainly 3 years on, we've overcome that. So now we get into this discussion around, if it's liquid, what kind of cooling architecture is best? And Jay hit on a few of these points, but it's probably worthwhile for me to reiterate exactly what the benefits are. So the first mover in liquid cooling was really water. So what we call single phase water, which is you move water through a plate on top of the chip, so it's direct to chip, but there's no phase change. And there's some issues with water that are now being openly discussed. A year ago, there was sort of everyone's dirty little secret, but water leaks. If there is a leak, it's going to destroy some very expensive servers. So if you think about, an 8-way GPU server as being somewhere between $250,000 and $400,000. A rack has gone from maybe a full rack 5 years ago was a couple $100,000 of IT equipment. Now maybe $3 to $5 million, right? Mm-hmm. So if you have a water leak, which you probably will at some point, there are a lot of hands on these things, right? So it's not really disparaging any of the vendors in that market. It's simply that you have third-party integrators, you have smart hands in the data centers playing with these things. There are going to be leaks. If there's a leak, it's going to be disastrous. So we thought long and hard about that. And we said, well, why don't we use what we call a dielectric or non-conductive fluid? The same thing will probably hold true with us, by the way. There are probably going to be leaks. But if we leak, can we avoid destroying this very expensive equipment that our technology is designed to protect, right? And our fluid doesn't. You can immerse the servers in the fluid we use, and it won't destroy anything. The other thing we looked at carefully was how to future-proof a cooling architecture. And that gets into this conversation around density. So you can think about density in kind of multiple ways. One, from a very high level, how much power density is there in a data center? So now you see articles and press releases around 200 megawatt, 500 megawatt, 1 gig data centers. So these things are incredibly power dense. In a rack, as Jay said, you no longer have, I think the average 5 years ago was about 7 kilowatts per rack. Now that's going to 100 kilowatts, 200 kilowatts. NVIDIA's talked about a reference design of 600 kilowatts per rack. So it's an order of magnitude more than it was just a couple years ago. So, and then the final density that's important to talk about is heat density on a chip. And that's what's called heat flux. And so you might hear about a GPU that is 1,000 watts, or the H100 was 700 watts. The Blackwell is going to be about 1,200 watts. The next gen is going to be maybe 2,000 watts. That is important, and obviously it affects the amount of residual heat that you need to pull away. Mm-hmm. But the real tricky part of that is how many watts per square centimeter. So again, another dimension of density. And for the next generation of chips, you really need a phase change. You need that movement from fluid to vapor. If you think about your high school physics, right? That's what captures a huge amount of this heat energy and pulls it off. So when Jay says he's an advocate of two-phase directed chip rather than just, single-phase directed chip, mm-hmm. That's the reason. It future-proofs the technology. So we've tested both heat fluxes and total wattages that are multiple generations into the future on our technology. ASHRAE, the consensus there is that water is going to start struggling when you get above a couple hundred watts per square centimeter, regardless of the flow rate for that water. And obviously there are some pragmatic limitations of flow rate. Mm-hmm. So these, when we talk about these, when we have these conversations, I feel sort of sorry for the data center operators because they have to figure out how to power these things. No one's powered a 600 kilowatt rack before. You have to figure out how to cool these things, how to maintain them, how to sort of manage your service and support protocols in a way that is sort of aligned with your legacy, right? Spot swapping servers and doing all of that. So there's a lot of challenges for these operators, and we're just trying to make it simpler. And that's really the underpinning of this relationship with ECS. We're just trying to create a great technology and then deploy it in a very pragmatic way to these operators.
Great clarification on so many of the points that Jay was making as well. Guys, I'm old enough to remember when the water beds were kind of a thing, and nobody ever wanted to talk about them leaking. And I remember my grandparents had one, and they put it in, and within a week they had completely destroyed their upstairs. So
Right.
I don't know. Every time I think of water beds or directed chip cooling, I think of water beds, and nobody ever really talking about them leaking.
You're bringing back some strange memories with the waterbed conversation, but we'll leave it at that.
Maybe
Anyway,
that's a follow-up webinar.
Different podcast.
Perfect. Okay, let's go with that. Let's go ahead and talk about performance. Speaking, and everything with regard to everything that you're talking about and the cooling and the power. Obviously, it's all coming to it is all driving to one specific end, and that is increasing the performance within the data center. Josh, why don't you talk to us a little bit about the implications on what you're doing with regard to performance within the data center?
Well, I think there are a couple, again, perspectives on that. One, AI does demand sort of proximate architectures, right? You have latency between servers and switches, between racks is really important in terms of the performance of an AI sort of machine. So you're not giving the luxury of being able to space out low density racks across a data center. Mm-hmm. So assuming you need a lot of density, and that's why we're talking about these almost absurd densities within a rack. Why do we need that? That's sort of a fundamental question. You need it because you're reducing latency within that cluster. So the idea is, how do you keep that cluster up and running? And that is a matter of managing this temperature. So the case temperature of the chips. You want to keep that case temperature well below the throttle point. So that's when a chip sort of self-regulates and says, I'm getting a little hot. I'm going to turn off and turn on, turn off and turn on to manage that thermal load. We want to avoid all of that. Mm-hmm. That is really disastrous in a AI environment. Some AI sort of software needs to restart entirely when you have too many throttling events. We obviously want to avoid all of that. So cooling becomes an integral part of the performance of that cluster. And I think that's really what we're driving for. There are other elements of it, software design, et cetera, but that's certainly our focus in this.
Excellent. Jay, anything to add on that before the next question?
Well, first, to violently agree with it. But also, I'll amplify the point, too, that where a lot of this compute is going isn't just in data centers. So a lot of these newer data centers don't have that nice, cushy climate environment control. It's not the computing resort. It's more like the computing hood. And, you've got a little bit messier environment at the edge. And remember, a lot of this new AI is going to happen at the edge, where there may not be that beautiful walled off climate controlled facility. So to amplify Josh's point too, I said earlier that AI is pretty much always on, right? So if you start getting into throttling, well,
I think that's a really good point, Jay. Right now, almost all the spend is going into very centralized learning models, very large learning clusters that are close to power sources, right? The prediction is over the next 2 to 3 years, about 80% of the spend is going to shift to inference. And inference means lower latency installations, more distributed small data centers in urban areas, et cetera. Yeah. It's not important for all the applications in AI, but it's important for many of them. And then you get into really rough environments. You might have a small module within a basement of a skyscraper, right? Yeah. Or in the corner of a factory. So I think Jay's point is a really good one, that you can't always guarantee sort of the sanctity of these environments as you move, as you distribute it out to inference machines. The nice thing about direct-to-chip is that it's a closed loop. It's clean. It connects to the chip itself. The refrigerant never is exposed to any environmental factors. You have no biocontaminants, no particulate contaminants at all. Yeah. So that's another real point that's motivating our drive to design higher and higher capacity two-phase systems.
So with regard to location, I got to believe that the location and the application are going to be kind of uniquely married. So let's talk a little bit about the kinds of organizations, the kinds of applications that these organizations might need, that may have the kind of the most immediate and the largest impact. Jay, you want to start with you? Let's talk about a little bit about what the application is as it relates to kind of the users or the organizations that will be immediately employing some of the applications that we're talking about actually enabling.
You know, Dean, you're walking me right into one of my favorite topics, as you know. You know, when I speak on panels, I always hold up my smartphone and ask the crowd, why in the heck do we call this thing a phone? Mm-hmm. Mine has over 300 applications on it. The phone, well, I'm an old timer, but the phone in most people's is the least used application on their smartphone.
Yeah.
So let's just dive into where this compute is going. And the answer is it's ubiquitous. One of the things that DeepSeek brought to the world was the poor man's AI. So now when you start looking at the application space, and I'll give some examples, and Josh, I'm sure you'll have some that you're seeing as well, but we've got a lot of media companies, for instance, that we do business with. But what happens when they have to upgrade their compute platform to the next level of accelerator? They go from H100 to Blackwell, and they're in a office condo somewhere in downtown mid-Manhattan. Well, how are they going to get a 50% uptick in power into that office? They're not. So this is one example of how the application solves a problem, notwithstanding the throttling and everything else. In some cases where you can't get the power, and media is a great example. They use a lot of compute. Their generative AI is, media on steroids. So, when you look at it from that vantage point, then let's get into education. We're doing a lot of work with several universities right now because, one, there's more study to be done, but two, the next generation of Josh and me is sitting in a classroom right now wondering, how do I become a nerd in a suit? Well, there you go. So you're going to, telemedicine. Think about the advantages AI will bring to medicine. And, I was talking with a colleague the other day who was at an AI conference, and, it was brought up, I wouldn't want to be a surgeon in 10 years.
Right.
And when you think about, where this is kind of going, I mean, just, personal story, I coughed up a kidney from my dad 10 years ago. The only doctor that touched me was the nurse that gave me the shot and said, count back from 10. I got to 9 and woke up with a bellyache. But that was all done by robotics. That's 10 years ago. So think about where we're going to be in 10 years in terms of AI and all the componentry that's being developed. And you take the fragmentation example of the smartphone, and then you start applying that to what kinds of problems does the combination of compute and advanced cooling solve, or better yet, enable. Because my first example was one of enablement. And I think that sometimes gets underscored, but it's real. We've got a lot of incumbent customers that say, hey, I got headroom here on my power budget. I got to go up, but I can't. And it's expensive to move. It's a lot easier to bring in a two-phase directed chip bundled between the two of us, Josh and myself, and say, we just extended your lease 3 years.
Yeah, let's stay on this theme. This is fun. Josh, your thoughts on the applications, the enterprise or end users that might be using this stuff first?
Yeah, there's this constant debate around is this sector overhyped? The sector being AI. AI is not a sector. It's going to be ubiquitous. I wouldn't want to pick stocks because who knows what's frothy and what's not, but I think it's probably underhyped. I mean, this is going to be, the tentacles of AI are going to go everywhere. Interestingly, the initial applications are going to sort of unemploy the highly skilled people. I mean, pathology in medicine it's pattern recognition. It's an obvious, I think AI is already outperforming pathologists. And pathology was one of those strange things that you actually got better. A 60-year-old pathologist was better than a 30-year-old pathologist, right? AI is already better than both of them. So you have diagnostics in medicine. You have individualized education, which is going to be a mind-blowing step function above where we have today. My team's already using AI for pipeline management, lead qualification and generation, nurturing. Seems like every week my team comes to me and says, can we have a new subscription for this AI driven sort of plugin? And it's hard for me to say no to any of them because they are productivity tools that advance. I think that the thing that I'm most excited about personally are the agentic AI applications, which there's been that promise for, a while. And I make that sound like 10 years. No, like 18 months. We're already so impatient that where is it? Where is it? Well, I think in the next few months, I'm going to get what I want, which is I get on a meeting. It already transcribes the meeting and sends out action items. It books a hotel for me and a flight for me for a meeting that's a follow-up. It does all that stuff for me. It sends a note to my team where it's relevant. I think we're going to see this monstrous sort of step in productivity, which is going to help companies run more efficiently and more smoothly. It's going to improve customer satisfaction, client satisfaction. It's going to do all these good things. The downside is obviously something for social commentary, and I think we need to talk about that and take it seriously.
Sure.
I will say that Jay made a point about these things. There's already community. My CMO sent me an article just last night about $64 billion worth of data centers have been installed because of community protests. Right.
Yep.
And those communities are protesting these for the right reasons, right? They're sucking water from the aquifers. Two-phase doesn't do that, necessarily doesn't do that. They are wasting power. So if you can secure 100 megawatts of power, it's better to use all of that for compute than to use 30 or 40% of that for cooling, right? So actually accelerating the adoption of some of these technologies is going to improve relations with the communities that these data centers operate in. And the other nice thing about cooling, sort of a side point, is that the sustainability sort of objective is exactly aligned with the business objective of just more efficient operations. So it's one of these few times in our lives where we don't have to argue about sustainability, even though sort of my company's mission is around sustainability, because it's perfectly aligned with OpEx savings, right? So it's not an extra spend; it's a reduction in spend. So those are important topics to consider as well.
For sure, yeah, and I lied. We're not going to stay on this theme. We're going to go to one that you guys just brought up because Jay, earlier you mentioned that the data centers in these locations, and we're thinking about these massive like monoliths on the outskirts of town. But what you were talking about is a small modular data center or micro data center in a strip mall and things like that. There's a sustainability element there as well. So let's talk a little bit more about sustainability and how. What the two of you are doing while both enabling kind of the advancement of these technologies, HPC and AI, how you are factoring in this kind of long-term sustainability element. I know we're off script, Jay, but I'm sure you can handle it.
Off script is how I live my life.
I believe it.
So Dean, thanks for the question. And, this is, again, it's a wormhole that we could really go far, deep and wide into because there's a lot more things to the green side of it. And, I always jokingly say, from California originally, but, the green thing when it's common sense is when it makes the best sense, and that's dollars and cents. Josh rightfully brought up the water problem that these big power hungry data centers, suck up. But what happens when you can repurpose facilities? Then you're not churning over dirt. So, that's another green benefit, right? If you're able to say, I'm not going to have to unearth something. So again, the water savings we get with two-phase, which again, doesn't you have to pull from it, but we also get more density. So you can put more compute in a smaller area. That's a big deal. Josh was talking about the rack densities. So all of a sudden you could have in a 100 square foot area, the kind of compute would take, columns in a traditional data center. Well, if you're repurposing Earth or buildings that are already on Earth, you're not digging up land. You're not disrupting the environment. There's all kinds of benefits that come from it. And then, of course, just the fact that you're not wasting, I think Josh said this a moment ago, the fact that you're not wasting electricity. You're better off putting all that towards the compute that has all these benefits in the application space versus throwing 30 or 40% of that juice into the garbage can, trying to blow fans over really hot devices, which, by the way, won't work anyway because the devices are already too hot and they're too dense. There's only so much air you can push before you get to that throttling bit, and that's just hyper inefficient.
Yeah, for sure. And Josh, I'm glad you brought this up because the whole idea of this expanding these data centers kind of to the residential edge, so to speak, has been wrought with challenges that the industry really hasn't seen before. Where you've got these communities coming at the data center operators or some of these land developers with torches and pitchforks, saying like hell, not in my backyard. And so, to your point, there is, if you can present alternative ways of making this work for both the end user and for the communities, the better. So anything more to add on that one?
The community protests are typically around water use, which we've talked about.
Yeah.
I think just a kind of a future facing statement I'll make on that is that there are a lot of companies that are partnering with us as well that are exploring completely refrigerant-based data centers. And I'm talking about scaled out refrigerant-based data centers using eco-safe, fluids, gases, et cetera, no water at all, which is important. The other community complaint is noise. And, I think the sort of Bitcoin miners haven't helped in this, in that they typically go low budget with a lot of fans, a lot of noise, and they've created this sort of backlash within communities. It's true with some data centers too, though, and liquid cooling is quieter. It should be almost silent. And so a lot of the complaints are going to go away, I think. And I think it's important that the sector gets in front of this, that the sector doesn't wait for regulation, et cetera, that we take it seriously, that we talk to these communities about what we're doing and how we're adopting these technologies that lead to very or maximally sustainable approaches.
Yeah, I think the more of these developments that get axed, the more serious folks are going to get about exactly what you're talking about. Okay, last question, guys. I'm going to kick it off to. In fact, Josh, we'll just stick with you. Put on your dreamer cap. If you're that little kid looking up in the night sky and seeing all these stars and wondering what it all is and where it's all going, I want you to think about this question in that way. Where exactly is all of this going? If you're going to dream a little bit, now's the time.
Well, I think where it's going is you're going to see an adoption of AI in almost every part of our life. And I think if we are thoughtful about the approach, there are definitely downsides, dangers, et cetera. But if we're thoughtful in our approach, it should add value to everyone's life. I think in terms of data center operations, what the goal would be is to have one large learning model software and application software that is very efficiently coded. So, we talk about gains in power efficiency through better cooling architectures. There's a lot to be gained among better coding as well, more efficient coding. And more specific accelerator chips that only do that function, that don't have a lot of overhead function and create a lot of power hungry and uses in residual heat. So that would be, I think, the ideal, that we really drive toward efficient data centers that adopt technology when it comes available, and then powers this new world that our kids are going to be living in. And, I think Jay's point about the smartphone is a good one. This stuff is going to be everywhere. And so we really need to think hard about this. If you look at the projections of AI growth, there's not enough power on Earth, generated on Earth, to power that growth curve.
Right.
So we're just going to have to get better about efficiently using every watt. We say make every watt count, and I think that's going to be a big part of this.
100%. Josh, thank you so much. J-Law, you have the final word.
God, I love that. Buckle up. So I want to violently agree with Josh, and I have to use a water reference that's probably, a good haiku here, but rising tides lift all ships. And that's where I look at, as I look at the AI. I hate just the AI terminology because ubiquity is absolutely coming. And we can be in a vicious cycle or virtuous. And Josh, thank you for making that point about the power, because that was one of my opening comments. We have to figure out how to do more with less. And that's just the nature of the beast. So as I look at it, it's AI for everyone. There's diseases that can be cured. There was a great pathology metaphor. One AI machine is worth a bunch of pathologists trying to figure out, or biomed, or what have you. But the ability to cure disease more efficiently, harvest food. I mean, there are agricultural applications we didn't even get into that can use water more efficiently to grow food in places where you're not supposed to be able to grow food. So when you look at the net of what's coming, there's just one positive thing after the next. I do think there is a social responsibility. And, you look at the neighborhood data center, just a little teaser for people to think about. All data centers will not be created equal going forward. And you could even have a small shed under the water tower in your community that becomes as powerful as one of these behemoth data centers that people are complaining about, but it brings the compute to the people. And that's really kind of an important piece of this. And it does it with, minimal impact to the environment. People's lives are made massively better. And we get to be at the center of this first early phase of making that true.
Gentlemen, I love it. I honestly, I feel like we could spend another 5-6 hours talking about this topic. Unfortunately, that is all the time that we have. Let's do this again soon. And for the viewers, thank you very much for tuning in. This has been the direct-to-chip innovation, revolutionizing data center cooling for AI and HPC, brought to you by ECS and Accelsius. Thanks for joining us. We'll see you next time.